Riley and Alicia support a 202-pound box in static equilibrium, holding the box in place, by pulling on the ends of a short rope that it is attached to an eyelet at the top center of the box. Riley is pulling the rope at a direction angle of 35 degrees with a force of 160.2 pounds. And Alicia is pulling the rope at a direction angle of 140 degrees. We're going to draw and label a diagram to model the situation, then find the force that Alicia is using to help hold the box in place. So I underline a couple of things that are important here. We have a 202-pound box. They're holding the box in place. And so what's going to happen then is that we'll have three equations. And so R plus N plus W will equal 0. So three of our vectors will equal 0, and that is what static equilibrium means. So given that the direction angle is 35 degrees, I'm going to start by drawing it on a coordinate plane. So direction angle, remember that is from the positive x-axis rotating counterclockwise. So it's a positive angle. Therefore, we have Riley's pulling the rope at a direction angle of 35 degrees. So I'm going to draw that vector. Theta is 35 degrees. And I will call this vector R. And so I'll use magnitude of R actually. So magnitude of R for Riley is 160.2 pounds. Now we have Alicia pulling the rope at a direction angle of 140 degrees. So I will say magnitude of N. We actually don't know what that is. We need to look for that. But we do know theta. Theta is 140 degrees. So far two vectors. We do have one more. So they're supporting a 202-pound box and holding it in static equilibrium. And so the box then represents another vector. It's going down. And so just an eyelet at the top is just kind of like some little, like a screw, and then the rope is going through it. So that's all that means. But you don't necessarily need to draw that. But you do need to represent the vector. So the vector is going straight down. And that magnitude, it's the weight of the box, is 202 pounds. Theta, there is an angle here. So from the direction angle, that is 270 degrees because it's going straight down, 270 degrees. So we're going to write three vectors. Remember, the general equation is V equals magnitude of V cosine theta I plus magnitude of V sine theta J, and so we'll write three of our vectors. Vector R for Riley, and R is, and the magnitude is 160.2 cosine of 35 degrees I plus 160.2 sine 35 degrees J. Then Alicia, N, so magnitude of N, because we don't know what it is, cosine of 140 degrees I plus magnitude of N sine of 140 degrees J. Then we have W, which is the weight of the box. The weight of the box is 202 cosine of 270 degrees I plus 202 sine of 270 degrees J. So I mentioned earlier that all the vectors, R plus N plus W, is going to equal 0 because they're holding the box in place. What we're going to do is we're going to solve for N. Now, it really doesn't matter if you solve for just the horizontal component or the vertical, it should be the same. So looking at the magnitude here, that should be the same, right? When we plugged in our magnitude for Riley, 160.2, it is the same. Same thing with the 202. So it really doesn't matter which one you solve for. So I'll go ahead and solve for the horizontal. So I'm going to write a horizontal equation, and that's just going to be R plus N plus W equals 0. So this is 160.2 cosine 35 degrees plus magnitude of N cosine 140 degrees plus 202 cosine of 270 degrees, and that equals 0. So one thing that I can change right away is cosine of 270 degrees, so cosine of 270. So remember that the x value is going to be 0. So 202 times that cosine of 270 is 202 times 0. So basically, this side just cancels out. So now all we need to do is solve for a magnitude of n. So we're going to subtract 160.2 cosine 35 from both sides, and then we'll divide by cosine 140 to solve. So magnitude of n, cosine 140 degrees, and subtracting that 160 from both sides, so minus 160.2 cosine of 35 degrees, and then dividing by cosine of 140 degrees from both sides. So when you go ahead and plug it in the calculator, you would get 171.31 pounds. So remember, when you're plugging it into your calculator, make sure you do have that negative, because then if you don't, then you'll end up getting a negative. Think about that cosine 140 degrees. That is going to be a negative value, right? So that's negative. So negative over negative will be a positive, which is why it gives us the positive of 171.31 pounds. If we wrote a vertical equation, we would get the same thing. So here's the work right here. I went ahead and solved for the vertical components, adding them all together. The sine of 270 degrees is -1, so this would be 202 times -1, so negative 202. And again, I want to solve for n, so I'll add 202 to both sides. Then I'll subtract 160.2 sine of 35 degrees on both sides. And then finally, we'll divide by sine of 140 degrees in order to isolate magnitude of n. So when we do that, plug everything in our calculator, we would get 171.31 pounds.